This is an introduction to alcohols, ethers, and epoxides. An alcohol is an oxygen that's attached to a carbon and a hydrogen. Ethers are oxygens that are single bonded to two carbon groups, and epoxides are cyclic ethers. Let's start by talking about the physical properties of alcohols. Alcohols have higher boiling points than similar molecular weight alkanes, and this is because they can undergo hydrogen bonding. If you were to rank the following compounds in order of increasing boiling point, this alkane only has van der Waals force and has the lowest boiling point. This haloalkane has van der Waals force as well as dipole-dipole moment. And this alcohol has van der Waals force, dipole-dipole, as well as hydrogen bonding, and has the highest boiling point. Low molecular weight alcohols, for instance if they have 4 carbons or less, are miscible with water. Alcohols are classified according to the carbon classification. So for alkyl groups, that is sp3 hybridized carbons, an alcohol can be classified as primary, secondary, or tertiary depending on whether the carbon is considered primary, secondary, or tertiary. For alcohols on sp2 hybridized carbons, we can classify them whether they're aromatic alcohols, in which case they're called phenols, and if they're attached to sp2 alkenes, then they're called enols. The suffix "ol" is used to indicate the presence of an alcohol if it's the highest priority functional group. If it's not the highest priority functional group, it's named as a substituent with the prefix hydroxy. Of the functional groups that we've learned so far, alcohols have the highest priority, and they have higher priority than alkenes, alkyl halides, and alkanes. Now let's try and name this compound. The alcohol is the highest priority functional group, so we're going to use the suffix "ol". We also want to give it the lowest possible number in the longest continuous carbon chain. And so we start numbering from here, 1, 2, 3, 4, 5, and 6. We have a 6 carbon chain. We have a stereocenter right here. We need to figure out if it's R or S. We have substituents, a 5-methyl group. We need to account for the alkene in the name, and we have 3-hydroxyl group. When we're assigning R and S, we will look at the priority, and the alcohol receives the highest priority. The alkene is the second, and this alkyl group is the third. This is counterclockwise, and so this stereocenter is S. Putting this all together, we start with S because we only have one stereocenter, and then we name the substituents. 5-methyl. This is a hexane chain. Since we have an alkene, we're going to put hex, which is the root, indicate the position of the alkene, followed by -ene, indicate the position of the alcohol, followed by -ol. So the name of this compound is S5-methyl hex 1-ene 3-ol. These are some common names of alcohols that you need to recognize. This is a phenol. This alcohol is attached to an allyl group, so it's allyl alcohol. Likewise, this is attached to a benzyl group, so this is benzyl alcohol. And this is isopropanol. This diol has a common name, ethylene glycol. And this triol has a common name of glycerol. Ethers have lower priority than alcohols, but higher priority than alkenes, alkyl halides, and alkanes. And ether is indicated with a substituent prefix of alkoxy, for example, methoxy, ethoxy. Now let's try and name this compound. The parent compound is a cyclopentane. We have 2 stereocenters that we need to name, and we need to figure out where to start numbering. We will start numbering from here. Both of these carbons have alcohols, but this one has an alcohol and an ether and will receive higher priority. So this would be 1, 2, and 3, 4, and 5. we need to assign the stereocenters R and S. So at this stereocenter, this is the highest priority group, this is the second, this is the third, and this is the fourth. If this is going at the back, then we're going anti-clockwise, which means this is an S configuration. For this stereocenter, we have the lowest priority group going in the back, that's the hydrogen. This is the highest priority, followed by this branch, and finally this branch that's going clockwise, and this is an R stereocenter. Now we need to name this ether group, and since this is an isopropyl group, the ether is going to be named as an alkoxy group. It's going to be an isopropoxy group. Putting this all together, we start with the stereochemistry. So we have 1s, 3r. The isopropoxy group is at the 1 carbon, so 1 isopropoxy. And then we can name the parent, which is cyclopentane. And then we need to put in the alcohols with the suffix -ol. There are 2 alcohols at the 1 and 3 position, and we end with diol. Some common names of ethers that you might run into are diethyl ether and methyl tert-butyl ether, which is abbreviated as MTBE, and these are commonly used solvents in the lab. This ether is commonly known as anisole. Common names of some cyclic ethers that you might run into are epoxide or oxirane, tetrahydrofuran or THF, tetrahydropyran or THP, 1,4-dioxane. These 2 are commonly used as solvents. 18-crown-6, this is part of the crown ether family and is usually used in SN2 reactions to capture the cation in this cavity. Epoxides are named as either epoxy substituents or as oxiranes if it's considered the parent chain. Alkene oxide is a common name of epoxides. Remember that epoxides are just cyclic ethers, and so they follow this functional group priority list. In this example, the common name is cyclohexene oxide, following the alkene oxide rule, and the IUPAC name is going to treat the cyclohexane as the parent chain, and therefore this is the epoxy substituent. And so you name it 1,2-epoxy cyclohexane. Likewise, if you look at this compound, the common name is cis-2-butene oxide, where this is considered the butene chain. The IUPAC name is going to consider this to be the parent chain, which means that it's going to end in oxirane. And so you've got 2 substituents on that oxirane, and so you can call it cis-2,3-dimethyl oxirane. Remember that you can also figure out the R and S stereochemistry at these centers and substitute it for cis.